Section R.2, functions and models. We're gonna deal with functions mostly in this section. So what is a function? Well, a function, by definition, we define a function is a relation for which each input has exactly one output. Input means we're talking about the x's. The outputs are the y's. So if I want to draw a mapping, it's call them 1, 2, 3, 4, 5, 7. Say 1 get mapped to 7, 2 get mapped to 4. So the input 1, these are the inputs. These are the outputs. So 1 get mapped, 1 goes with 7, 2 goes with 4, and 3 goes with 5. If I close that with braces, that gives you the relation, which is a function. Because for every input, for the input 1, the output was only 7. For the input 2, the output is 4. The input 3, the output is 5. So for every input, there is exactly one output. If we look at other examples, 2, 7, 3, 4, 1, 5, 2, 4, we're going to see if this is a function or not. We look at the inputs. The input 2, what is the output? 7. The input 3, this is the output. Input, output, input, output. Oh, notice 2 has 2 outputs, more than one y value. So the number 2 has more than one y value. So it's not a function. Not a function. Since 2 has more than one output. We can look at another example. 3, 8, negative 1, 0, 1/2, 2, 4, 7. Is this a function? Is this a function?
Yes.
Yes, it is a function. Because for every input, there is exactly one output. It is a function. If we take the x values, 3, negative 1, 1/2, and 4, that gives me the domain. That's the domain. And if you take the y values, 8, 0, 2, and 7, that's the range. That's called the range. So domain has to deal always with x values, range y values. Domain means input, range output. Now functions are written in the form f of x. That's a function in the variable x. For example, f of x is x plus 3. That's a function. So if I want to find values for such a function, So let's say I want to find f of -2, f of 0, f of 1, f of 5. So how do we do that? Well, f of -2 means I'm just going to substitute x -2. F of 0, that's 0 plus 3, which is 3. F of 1, 1 plus 3, 4. F of 5, 5 plus 3, 8. So I can, in other words, I can do this input and output. So the inputs are the x values, -2, 0, 1, and 5. The outputs I got 1, 3, 4, and 8. These are called outputs. I'll give you another example. You try it. Let f of x equals 3x plus 5. Find and simplify f of -2, f of -x, and f of x plus h. So first we find f of -2 by replacing x with -2. That's a -6 plus 5, -1. F of -x. This means I need to replace the x with -x. So I replace this x with -x. Then multiply the negative in. So the answer doesn't have to be an actual value. It could be like in terms of x or y or h or anything else. The next one, f of x plus h. F of x plus h, we're going to replace the x with x plus h. Then you distribute 3x plus 3h plus 5. Can look at another example. F of x equals 2x minus x squared. We are asked to find f of x plus h and f of x plus h minus f of x all over h. Okay, so we can go over the first one, f of x plus h. We replace x with x plus h. So I replace this and this. But don't leave it like this. We need to simplify. For the first one, we can distribute the 2 in. Keep the minus out. And for this one, we square the first one. 2 times x times h and h squared. Then keep the first terms the same. Multiply the negative sign in to get the final answer. Nothing can be simplified. We can't combine fractions or anything like terms. Next, we have the next part that looks more challenging than the first one, but notice it uses the first one in that sense. It uses the first one. So what we're going to do is we need to find f of x plus h minus f of x over h. f of x plus h is 2x plus 2h minus x squared minus 2xh minus h squared minus the function is 2x minus x squared all over h. So this stays the same. Same. I need to clean up the parentheses at the end. By multiplying, there's a -1 here.
Professor,
multiply.
sorry, but you're muted. We can't hear you.
No one told me earlier. Okay, so I was multiplying, simplifying the first one to go back. So this is 2, I replace every x with x plus h. And then I multiplied the 2 in. 2 times x and 2 times h. Minus. This one, it was a formula that we recalled in the previous section for a plus b squared. A squared plus 2ab plus b squared. Very important to know. And that's what I used from here to here. And then as a final step, I multiplied this negative. That negative means negative 1. Negative 1 in. Multiply, multiply, multiply. And that's what I got for this one. The second one is more difficult, it looks like, but we can use this one to help us for the second one. And how is that? So they want us to find f of x plus h minus f of x all over h. This one we already found. So what I did, I just substituted that in here, minus the function itself, 2x minus x squared, all over h. Then I keep the circled part the same, multiply the negative 1 in, minus 2x. Negative 1 by negative is positive x squared, all over h. So on the top, what do we have? These cancel each other. Negative 2x cancel. On the top, we're left 2h minus 2xh minus h squared over h. Then you take an h out, 2 minus 2x minus h all over h. These cancel. I factored an h out. So the only thing left, 2 minus 2x minus h. So this is very important stuff. We're going to use it later on. All this is associated with functions.
Professor, is this was the f x plus h minus f of x over h, is that difference quotient?
Yeah, that's called difference quotient. This is
okay.
Difference quotient.
Thanks. Okay, thank you.
Next thing I want to teach you about functions, what we call the vertical line test. Vertical line test. The vertical line test is a tool for us to tell if a given graph is a function or not. Does it represent a function or not? So let's say we have something like this. That's just a graph. You know, these are just random graphs. I'm just drawing. So the vertical line test says if you draw vertical lines for any of the graphs, if it crosses always at one point, then it is a function. It's a function. So the first one is a function. What about the second one? Is that a function or not?
Yes.
Yes, it is. Because every time you draw a vertical line, it crosses the graph at exactly one point. What about the next one?
Yes.
This is a function?
No, the third graph is not a function.
This is
because
not.
it crosses.
It crosses the graph at more than one point,
Right.
not a function.
Right.
Next one, is this a function or not? See, if you graph it
Yes.
here, 1, 1, 1, 1, all the way to this point. Here it crosses at this point, not at the circled point, because that's like an empty thing. There's nothing there. So yes, it's a function. What about the next one? Yes, 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 yes. Boom. Oh, no, it's not.
The last one, just because the points are close, that means not a function?
Not because they're closed, but because those points are part of the graph. So when we drew a vertical line, it went through more than one point. It went through 2 points of the graph. So these 2 pieces are part of the graph. Yeah.
First, I just have a quick question.
Yeah.
On the OneNote, how do you zoom out
Uh,
on the lecture notes? Thank you.
Yeah, so other options, if we are given a function like this or a relation like this, we need to check if this is a function or not. Is the first one a function or not? What do you guys think? Is the first one a function? Well, if I draw a line, no matter where I draw the line, always goes through the one point. So this is yes, it's a function. This one, it's not, because it goes, it passed through more than one point. It's not a function.
So basically, as long as it touches only one point, it's a function.
Yeah. That's called vertical line test. Another thing to review in functions called piecewise functions. So what are piecewise functions? Piecewise functions, let's say they give us a function like this. X if x less than 1. X minus 1 if x bigger than or equal to 1. And they ask us to graph it. So we're gonna graph the first one, y equals x. Okay, y equals x. If you forgot how to graph the line, you can pick x, y values. Take 0, 1, 2, 0, 1, 2. So you get 0, 0, 1, 1, 2, 2. This is the line. They said only graph it under this condition that x less than 1. X less than 1 means to the left of 1. Less means to the left. So this is x equals 1. So imagine there's like a wall here or something. Only keep the one to the left. Anything to the right, get rid of it. Okay, and it says only less. So at 1, you make an open circle. Means we don't include the 1. For the second line, y equals x minus 1. Similar way, you can pick x values 0, 1, 2. When x is 0, y is negative 1. When x is 1, y is 0. 2 is 1. So I'm going to graph it with a different color. 0, negative 1, 1, 0, 2, 1. This is the line. But they said only graph it from 1 to the right of it. Bigger means to the right, means anything to the left of 1, you need to get rid of it. Any questions about this so far?
So you just plug it in numbers so you can find the graph, basically?
Yeah, yep. Always. So now, out of this, is this a function? If you use a vertical line test. No. The above graph, is it a function or not?
Yes.
Is a
Yes.
function, because since we say it passes the vertical line test. It passes the vertical line test. We can add more. We can ask you for the same problem. We can ask you to find f of 2 and f of 0. So we want to find out f of 2 and f of 0. F of 2, you want to say like, wait, where am I going to find f of 2 from? Where? I have two functions. Do I substitute in both, in the first or second? Well, if you want to read this function here, this one, this is saying use the function f(x) equals x when x is less than 1, and use x minus 1 when x bigger than or equal to 1. X bigger than or equal to 1. So when they said find f of 2, which is bigger than 1, so I'm going to use the second equation, x minus 1. So it's going to be, I'm going to use x minus 1. So f of 2 would be 2 minus 1, which is 1. Now they want us to find f of 0, which would be the first one, f of x equals x. So f of 0 is simply 0. I'm going to give you another one and you try it. I'll try to include 3 equations. X less than 0, x equals to 0. So for this one, try to graph it and then find f of 0, f of 3, and f of negative 2. Try this one. Okay, we can move on then. We are going to graph it one at a time, one function at a time, or one piece at a time. The first piece is y equals x squared. You don't have to show all the step-by-step points. Like if you know that the graph looks like this, it's a U shape, you can do so, it's fine. But we need to go back and check the condition. It says graph it when x less than means to the left. To the left of 0. So that's what we have. Next one, we have y equals negative 3. Y equals negative 3. A lot of people think it's here. It's really there, but let's see what we have. X equals negative 3. Y equals negative 3. So that's y equals. When x is 0, that means 0, negative 3. That's a point. 0, negative 3. So it's only a point, just a dot like this. The last one, y equals negative 2x plus 3. Well, we can pick x equals 0, y 3, x equals 1, y 1, x equals 2, y negative 1. I'm substituting into the line. 0, 3, 1, 1, 2, negative 1. So it says graph it above 0. So like that. That's the graph. Then they want us to find f of 0. F of 0 means when x is 0, what do you get? Well, when x is 0, it's the second one. Y is negative 3. When x is 3, 3 is bigger than 0, so I'm going to use this one. So substitute the 3 in. Negative 6 plus 3, negative 3. F of negative 2, that's the first one. So it's negative 2 squared. You square everything. So that's why you get positive 4. Not negative 4, positive 4. Any questions about this?